Today's topic is continuity. Continuity at a point. Continuity at a point A. This A is a point taken from the domain of the function. Usually we take for real functions, the domain of the function is always real numbers or a subset of real numbers. So A is a point from the domain of the function, and continuity at A is defined as f y equal to f of x is a function. This function f is said to be continuous at a x equal to a if limit x tends to a of f of x equal to f of a. And as limit x tends to a means there are two meaning. X approaches a very closer and closer to a from either side of a. So we can also write this limit exists if a left hand limit equal to a right hand limit equal to the function value at a. Now one more thing you have to know, that when do we have to go for this LHL RHL is whenever x tends to a minus with a different function. That means when x approaches a minus means x is taking values left of a. So here we say x approaches a minus, and here we say x approaches a plus. That is from right of a. So in other words we can say that x approaches a minus means x is less than a, and x approaches a plus means x is greater than a. X is taking values greater than a. So this, when we take x approaches a minus and x approaches a plus, this formula when do we consider is whenever you are given a function when x less than a and when x greater than a, if you are given two different values for the function. For example, here if it is x square and here it is x square minus 4. So these two cases only we will go with it. Otherwise we will use this definition. So now let us go for the questions, and before that some general things you have to know. That is, a function, every polynomial function is continuous. When you say that a function is continuous means it is continuous at every point of its domain. So second one, that sine functions are continuous. We know that the sine function goes like this, passing through origin. Sine functions are continuous, cosine functions are continuous. Then the third important function is modulus function. Modulus function, you know it is V shape. This modulus function is continuous, especially at the point 0. It is very important. You write this function like this, f of x equal to modulus x, and this function is also continuous at 0 and also at every point of its domain. Now for differentiability, what is the definition of differentiability is f dash a equal to limit of Newton's ratio, that is f of a plus h minus f of a by h as h tends to 0. So this, if this limit exists, we do say that the function is differentiable, and it is denoted like this, f dash a, or can also be written as dy by dx at x equal to a. So the differentiability is also a point property. Now if you consider all the continuous functions and all the differentiable functions, with set theory I am just making you understand, D is a proper subset of C. D is all the set of differentiable function. C is the set of all continuous functions. You can see that every element in D is also an element in C. Means if a function is differentiable, then it is definitely continuous. But if a function is continuous, not necessary that it is always differentiable. For example, suppose we consider here f of x equal to mod x. This function is continuous, just now I have told, but it is not differentiable at 0. Very, very important to know that f of x equal to mod x is continuous at x equal to 0, but not differentiable at x equal to 0. This is a very important concept, and we can expect one question in MCQ. For example, if you are given f of x equal to modulus 2x minus 1. This function is the special point we are taking. This function is always continuous, modulus function is always continuous, but especially this corner point, where this corner point comes, wherever this equal to 0, what you get when this is equal to 0 means x is equal to 1 by 2. So when you take x equal to 1 by 2, this function is continuous. Wherever this is 0 also, the function is continuous. But this function is not differentiable at x equal to 0. This function is continuous at x equal to 1 by 2, but not differentiable at x equal to 1 by 2. Another function, if you consider f of x equal to x minus 4 by 3. Modulus function. So, you just see, especially the MCQ comes like this. Wherever this is equal to 0, or what is that, when x equal to 4 by 3. When x equal to 4 by 3, it is continuous but not differentiable. This is very important to know. Another function we can take it as f of x equal to modulus sin x. Wherever this becomes 0, for example, x equal to 0, pi, these are all places where this becomes 0. X equal to 0, pi, or any odd multiples, any integral multiples of pi, at this becomes 0. This is continuous at all this point, but not differentiable at this point. Another example is modulus sin x minus cos x. So here also, wherever this is 0, for example, x is equal to 45 degree. When x equal to 45 degree, you can get here 1 by root 2 minus 1 by root 2 is 0. So I am taking one x equal to 45 degree or pi by 4. At this point, it is continuous but not differentiable. So this is one of the expected questions. The next one is your integer function. F of x equal to integer value of x. This everybody knows that it is 1, 2, 3, 1, 2, 3. The graph is coming like this. From 0 to 1, this one, 1 to 2, it is 1, 2 to 3, it is this. So integer value of 2.1, that means it is 2. Integer value of 2, that is also 2. So whenever we consider the points x values from here to here, you will get the y values here. These points are not included. So wherever there is a cut in the graph, you can say that the function is not continuous. So this integer function is not continuous at all the integral points, and if C is set of all differentiable functions, this is a Venn diagram we use. Usually it's say if C is not continuous means it cannot be differentiable also. C is not here, then it will be outside this. Okay, so f of x equal to integer function of x is outside of this Venn diagram, so definitely it is not there in D. So when a function is not continuous means it definitely not differentiable too. So this integer function is not continuous at the integral points, and also it is not differentiable at the integral points. Now let us go to the questions. The first one is the function f of x equal to modulus x minus 5 is, you can see here, continuous at x equal to 5, it is correct, but it is not differentiable at both continuous and differentiable. That is also neither continuous. So the final answer is this. You can also be very careful. Sometimes the question is asked the function f of x. Which one of this is not true? That also could be one of the questions. Next one, question number 2. F of x equal to mod x plus mod x minus 1. Then f is continuous at 0 as well as at 1. It is continuous at this, wherever this is becoming 0, and this quantity becomes 0 at 1. So at these points it is continuous but not differentiable. This you have to be very careful. So f is continuous at 0 as well as at x equal to 1. F is continuous at x equal to 0 but not at x equal to 1. So this is a correct answer. The value of b for which the function is continuous is. So we have to find out the value of b, and what is given is the function is continuous. A function is continuous means it is continuous at every point of its domain. And what is a domain? Means what are the x values here? You see x is starting from 0 to this. So your domain is from 0 to 2. Now the function is continuous means it is continuous at every point in the real numbers between 0 and 1. But one particular point you have to consider. It is always this point where this inequality changes. So you have to take that f is continuous at x equal to 1. Then you have to go with the definition. The definition is LHL equal to RHL definition, which is equal to limit x tends to 1 plus f of x equal to f of 1. So what do you mean by limit x tends to 1 minus f of x? How do we find? This f of x you will replace in the next one. Limit x tends to, you can remove this condition once if you replace this function. What do you mean by x tends to 1 minus? Don't get confused with minus 1. It is 1 minus means only meaning is that x is less than 1. So when x is less than 1, then what is f of x? From here you have to decide. There are two f of x. From there, x less than 1 means it is 5x minus 4. And now you remove this condition and you write only x tends to 1, which is equal to limit x tends to 1. Here what is f of x? When x greater than 1. X greater than 1 means you will get 4x square plus 3bx equal to f of 1. F of 1 means when x equal to 1, what is the function value? So this is function, and when x equal to 1, when you put x equal to 1 here, you will get 5 minus 4, that is equal to 4. From here, how to get the limit is, the polynomial's limit means you will simply replace x by 1. So here you will get 1 equal to, you will put here 1, 4 plus 3b equal to 5 minus 4 is, sorry, it is 1. 5 minus 4 is 1. From here you will get 3b equal to minus 4 and minus 4 plus 1. So it is minus 3 and b equal to minus 1. So this is the answer. The function f given by sin x by x. You can just read the question. The function f given by this is continuous at x equal to 0, then what is the value of k? So it is given that f is continuous at x equal to 0, then you can write limit x tends to, now you have to think whether x tends to 0 minus or 0 plus, you have to go or not. You need not have to go because here x less than 0, x greater than 0 is not given. So we will write this, the first formula, it is f of 0, and f of 0 write करना बहुत easy है. it is k by 2. The function value at x equal to 0 is k by 2, and here it is limit x tends to 0 of sine 3x by x. Now children, what you do is you can apply L'Hospital's rule here. You need not have to go for the standard limits and all. Whenever you are getting undefined form, when you put x equal to 0, that means when you put x equal to 0, the denominator is 0. It is not defined. Then how to find the limit is, the L'Hospital rule says that, L'Hospital rule say, it is again same as limit of this f dash x by g dash x, means derivative of the numerator divided by derivative of denominator. Derivative of denominator is 1. Derivative of numerator is derivative of sine 3x is, it is sine of 3x, so cos 3x into 3x ka derivative, that is 3, equal to k by 2. Now again you put x equal to 0 and see whether this function limit is defined or not. When x equal to 0, there is no problem, denominator is not 0. So the answer is 3 into cos 0. Cos 0 we know it is 1. So 3 equal to k by 2 or k equal to 6. The next comes our function f of x equal to, this is a greatest integer function. This is the greatest integer less than or equal to that x. It is continuous at everywhere. So we know it is a step function. Greatest integer function comes like this. It is not continuous. It is not continuous at the integral points. Continuous at integers, no, this is not correct. Continuous at non-integer point, that is correct. Non-integer points, those points where x is not an integer. The function, the values of a and b for which this function is continuous. The values of a and b for which this function is continuous. So what you will do is, it is given only continuous, and you have to take some point. Continuity is a point property, so you consider that f is continuous at x equal to, which are the points you have to consider is, this is a suggested point, x equal to 2 you have to consider, and also we have to consider x equal to 10. This was 6. X equal to 10. These 2 points continuity you consider. So when you consider the continuity at x equal to 2, what you can write? Limit x tends to 2 minus f of x equal to limit x tends to 2 plus f of x equal to f of 2. So इसमें से कोई एक equation ही निकालना है. f of 2 is very easy to write, so you write that. X less than 2 means the same 5 will come, so you will consider this, that is limit x tends to 2 of f of x. X tends to 2 plus means x is greater than 2, so the function is ax plus b. Putting x equal to 2 you will get here 2a plus b equal to 5. Similarly for x equal to 10, when you consider f of 10 is, you can write f of 10 is 21, and that is the same as limit x tends to 10 minus 1, that is 10 minus, that is ax plus b will consider, and its limit is, putting x equal to 10 you will get here 10a plus b equal to 21. Now on solving this, what is that? The other one is 10a plus b equal to 21. On subtracting you will get minus 8a is equal to minus 3. Sorry, 3. It is 3. Is it 10 or not? I don't know. A equal to 3 by 8. Oh, sorry, it is 21. Okay. So it is minus 16. So A equal to, it is 2. A equal to 2. It is coming here. And now you see all the other things, a equal to 2, then b must be equal to 1. So here also substitute a equal to 2, b equal to 1. So we will get 5. So this is answer. Find the value of k for which f is continuous. Here also it is only given continuous. So we have to consider it is continuous at this is a suggested point. It is at x equal to 5 you have to consider. So we will write limit x tends to 5 minus f of x equal to limit x tends to 5 plus f of x equal to f of 5. F of 5 you write first. F of 5 means the function value at x equal to 5. So this function value you have to consider, and there you put x equal to 5, you will get 5k plus 1. Now one of this you will consider, that is 5 minus will not consider because the same thing will come. So if you consider this, that is it becomes the limit x tends to 5 plus means it is 3x minus 5, and its value is it's a polynomial, so limiting value will be by putting x equal to 5 we'll get. So it is 3 into 5 minus 15 equal to 5k plus 1. So it is 15 minus 15, that is 0 equal to 5k plus 1, or 5k equal to minus 1 and k equal to minus 1 by 5. It is minus 1 by 5. The next one, find the value of k. Find the value of k so that the function is continuous. So here the continuous, which point you have to consider at x equal to pi by 2. So here you consider f is continuous. No need of writing it actually. When you do it in the exam hall, you have to think that it is continuous x equal to pi by 2 and write the definition. X tends to pi by 2 plus you are considering. You need not have to consider this because x less than pi by 2, x greater than pi by 2 nahi hai. So only directly you can write, which is equal to f of pi by 2. And what is f of pi by 2? It is 3. And left hand side is limit x tends to pi by 2. What do you mean by x tends to pi by 2? That means x never equal to pi by 2. So when x never equal to pi by 2, the function value is this. So you can write here, it is k cos x divided by pi minus 2x. Here also children do the L hospital rule. That will be easy. Because when you put x equal to pi by 2, denominator is becoming 0. So you can apply L hospital rule. That is limit x tends to pi by 2. Next you have to write the derivative of k cos x, that is minus k sin x divided by derivative of pi minus 2x. Derivative of pi is 0, derivative of minus 2x. With respect to x only we are doing. So it is minus 2 equal to 3. Now this problematic denominator being over means denominator is not now 0. So now you put x equal to pi by 2 to get the value of the limit. So what you will get? X equal to pi by 2, sin pi by 2, it is 1. So k by 2 equal to 3 or k equal to 6 is your answer. K equal to 6. Find the points of discontinuity of the function. X square into sin 1 by is very important question this. Here this function is how to find the limit. If it is continuous at 0 only, there is only one danger point, that is 0. All the other point the function is continuous, because when x less than 0 and x greater than 0, throughout the domain the function is product of one polynomial and a sine function. So if two functions are continuous, then their product function. If f and g are continuous, then f into g is also continuous. But when x is equal to 0, you have to be careful, because now we are going to check only this danger point, that is x equal to 0. How to check? X tends to 0 of f of x and f of 0 you have to check. F of 0 is definitely 0. Now what is the limit of this? Limit x tends to 0, f of x will be this, because x not equal to 0. X tends to 0 means it is x not equal to 0. When x not equal to 0, what is f of x? It is x square into sin 1 by x. Now how to find its limit? You have to apply the Sandwich Theorem. What Sandwich Theorem says is, Suppose we have two functions, f and g are two functions, and h is a function like a sandwich. And at this point A, suppose limit of f of x is equal to limit of g of x equal to some k. Means what is the speciality of this function? You see, wherever h is coming, this is h function. Wherever h is coming, this h of x is lying between g of x and f of x. G of x and f of x, and limit of g of x, limit of g of x and limit of h of x are equal to k. Then the sandwich theorem says that limit of h of x is also as same as that of the limit of g of x and f of x. So that when you apply, how to apply is, you know that sine 1 by x, its maximum value is plus 1 and minimum value is minus 1. Now x square is a positive quantity. You can multiply inequality with a positive quantity. The inequality does not change. Now take the limit x tends to 0 of this. That is equal to 0. Limit of this. Limit of x square equal to 0 as x tends to 0. That means these two functions are having the same limit 0. Then definitely this also has the same limit 0. So its limit is 0. And you can see that f of 0 is also 0. So that means the function is continuous at 0 and it is the continuous at other points also. So that means there is no point of discontinuity. There is no point of discontinuity. The next one is, now you must be able to find out the points of discontinuity. The next question is to find the point of discontinuity. Find the point of discontinuity. What you have to do here is, only the danger points are this. These points continuity you check and decide. Now to check the continuity at the point minus 1. What you have to check? Left hand limit must be equal to right hand limit must be equal to the function value at minus 1. The function value is minus 2. What is the left hand limit? Limit of the constant is a constant, that is also minus 2. What will be the right hand limit? It is limit x tends to minus 1 of 2x. So we can see that limit x tends to minus 1 of 2x is 2 into minus 1, that is also minus 2. So it is continuous at this point. Now you take the point 1. Then here function value at 1 is 2. Left hand limit is the limit of 2x as x tends to 1. So that we will get by 2 into 1. So everything is 2. That means there is no point of discontinuity. For what value of k the function is continuous at x equal to 1? So you are given that the function is continuous at x equal to 1. And you can write now the definition of continuity. X tends to 1 minus 1. Minus 1 f of x equal to f of minus 1. And f of minus 1 is the function value when x equal to minus 1. When x equal to minus 1, the function value is k. Now this is how to find limit x tends to minus 1. X tends to minus 1 means x is not equal to minus 1. So in that case, what is the function is? This is a function. X square minus 2x minus 3 by x plus 1. So what happens here when you find this limit? When you put x equal to minus 1, here the denominator becomes 0. Immediately you apply the L'Hopital rule. So what L'Hopital rule says? X tends to minus 1, derivative of this by derivative of this. So it is 2x minus 2 by derivative of x plus 1 is 1, which is equal to k. Now to get the limit, you put x equal to minus 1. So we'll get minus 2 by 1 equal to k, or k equal to minus 4. So k equal to minus 4 is the answer. Find all the points of discontinuity of f given by this. Here also see, limit of a constant is always a constant. So your danger points are 1, 3. This only you have to check. No other point you need to check for finding the point of discontinuity. Now to take the continuity at 1, you have to take what is the left hand limit. Left hand limit will be limit of 3. Limit of 3 will be 3. It is x equal to 1 here considered. Limit of left hand limit will be 3. And what is the right hand limit? That will be 4. Right hand limit is 4. They are not equal. So that means this is a point of discontinuity. Now you consider next point x equal to 3. Left hand limit will be the limit of 4. Limit of 4 is 4. Right hand limit will be limit of 5. That is 5. They are not equal. LHL equal to 4 and RHL equal to 5. They are not equal. That means this is also a point of discontinuity. So there are 2 points because 10 and 0 are not coming because there is no left hand limit here. The continuity itself is defined as the right hand limit and the function value. So the right hand limit is 3 and the function value at x equal to 0 is also 3. So the function will be continuous at 0. Similarly, the function is continuous at 10 also. Similarly, the function is continuous at 10 also. So only 2 points which are there, 1 and 3. So 1 and 3 are the points of discontinuity. So here x minus 1 into sine 1 by x when x is not equal to 1 this. Then which of the following is true? This type of one question you can always expect. Which of the following is true? See, f is continuous, differentiable, everything. It is only about differentiability. F is differentiable at 1 but not at 0. F is differentiable at 0 but not at 1. So let us check the differentiability at 1 as well as at 0. So to check the differentiability at 1, what is the definition? F dash 1 equal to limit x. देखो f dash 1 में how you will think about the Newton's ratio. When f dash 1 comes here, the second term is f of 1. The first term can be 1 plus h or it can be any number. And I took it as x because here it is coming x minus 1. So when you consider, here it is coming x minus 1. When you consider this is f of x, denominator should be this x minus 1. And then x tends to 1. So what is that? Which is equal to limit x tends to 1 of f of x is this minus f of 1 is 0. So you will be getting this as limit x tends to 1 x minus 1 into sine 1 by x minus 1 by 1 by x minus 1. And x minus 1 will cancel because x is not equal to 1 or x minus 1 not equal to 0. And when x tends to 1, this function is not a fixed value. It is an oscillating value. It may oscillate between 1 and minus 1. So this is an oscillating value. That means its value will change from minus 1 to plus 1. So this derivative does not exist. Then what about x equal to 0? So f dash 0 is, what will be that limit? F dash 0 means here it will come f of 0. Here you can write it as f of x divided by x minus 0 and x tends to 0. So what is f of x? This is f of x. As x tends to 0, you are getting a fixed value. When you are putting x equal to 0 here, what you will get is minus 1 sine 1 by 0 minus 1. When you are writing this, I am writing in the left hand side, which is equal to f dash 0 equal to limit x tends to 0 of f of x minus f of 0 by x, and that is equal to limit x tends to 0 of f of x is x minus 1 into sine 1 by x minus 1 divided by x. And you can see that when you differentiate this limit exists. When you differentiate this, here it becomes 1, and here you will get product rule and you apply and all, you will get some finite quantity. So this value exists. So your answer is f is differentiable at 0 but not at 1. Even then you can see that you can take the derivative by taking product rule also. So both the ways you can think. So it is differentiable at 0 but not at 1.